Swayam Prabha. Digital India. Educated India.
Now, if I have a single variable function, a scalar function, scalar valued scalar function, and if I say f of x plus f of minus x is equal to 0, you will immediately say that f of x is an odd function of x, an odd function, right, because f of minus x is minus f of x. This implies f of x can be represented as a polynomial a I x power 2i minus 1 I equal to 1 to n, right, wherein it will be in terms of odd powers of x. In particular, this can be of the form a1 x, right. So, that is what you will immediately conclude based on this restriction. Similarly, now what you have is a function of 3 variables, 3 functions of 3 variables. So, how will that depend upon the normal is the question. So, you have a restriction this is 3 functions of these 3 variables which are the components of n must be equal to minus f of n. Okay. So, this is again a definition of an odd function. This implies f of n is an odd function. In particular, what Cauchy has shown is this f as a function of n is a linear function of n. You will understand what you mean by a linear function of n shortly. N's T's of n can be written as sigma times n, where this is what is called as the stress tensor, okay, or the linear function that maps n to T's of n. Okay. For this, now you have to go into some tensor algebra to understand what this linearity means, how do you define linear functions and so on. So, we will understand first what is a linear function. Okay. A function is said to be linear if it obeys superposition and scaling. What does this mean? If x and x1 and alpha times and x2 and alpha x1 plus beta x2 belong to the domain of the function for some constant alpha and beta, then f of alpha x1 plus beta x2 must be equal to alpha times f of x1 plus beta times f of x2. Okay. If the function obeys this rule, then it is said to be linear. Okay. This implies f of x is a linear function. Okay. This does not mean that the graph of the function will always be a straight line. Yes, it is straight line for a scalar valued function, but if you think of the function being a differential equation, then the solution to the differential equation need not be a straight line, but the differential equation still be a linear differential equation. Okay. So, all that you have to do is check whether this relationship holds for the given function. Okay. Now, what am I interested is function of 3 variables, 3 functions which are dependent on 3 variables. Okay. That is Tx, Ty, Tz, the components of the traction along x, y and z can be written as Nx, Ny, Nz, where this is A11, A12, A13, A21, A22, A23, A31, A32, A33. Is this a linear function? In other words, is T equal to A times n a linear function? So, what should I do? Is a linear function for given matrix A. Okay. So, what should I do? I have to check whether f of alpha n1 plus beta n2 is equal to alpha times f of n1 plus beta times f of n2, right. So, let us go ahead and check. So, what do I have? I have T is equal to A, which is given, times alpha times n1 plus beta times n2. This will be A times n1 alpha plus beta times A times n2, because alpha and beta are scalars, alpha beta are scalar valued scalars. So, this is nothing but alpha times f of n1 plus beta times f of n2. Okay. What we found is this to be a linear function. Okay. Now, let me show you that if I add f of x defined as alpha x or mx plus c, the curve, this is a scalar function, x is a scalar value. Okay. You will see that this does not satisfy the requirement that f of alpha times x1 plus beta times x2 would be m alpha x1 plus c plus beta m x2, it will be alpha plus c. This is not equal to that. Okay. Only if it is then alpha times c and beta times c. This is not equal to that. What is this equal to? This is equal to m times alpha x1 plus beta x2 plus c, which is alpha m x1 plus beta mx2 plus c. Okay, this is not equal to alpha times f of x1 plus beta times f of x2. Okay, so this is not a linear function. Linear line, all this implies is linear curve need not mean the function is linear. C has to be equal to 0 for function to be linear. Okay. So, thus for the vector mapping of 3 variable functions to 3 functions, you will find that what we add, this vector t mapped as a times n to be the most general linear function. Okay.